Washington built a technological wall around the most powerful AI chips on Earth. The goal was simple: keep advanced compute out of China. No chips, no AI dominance. But what if that wall just cracked? Recent reports suggest Nvidia's most advanced architecture, Blackwell, may already be powering AI development inside China. If that's true, this isn't just a policy failure. It's a crack in America's semiconductor containment strategy. Blackwell is not just another GPU. It represents a generational leap in high-performance computing. These chips are engineered to train massive AI systems, models with hundreds of billions, even trillions of parameters. They reduce training time. They improve energy efficiency. They lower the cost per computation at scale. And in the AI race, scale is everything. Access to Blackwell-class hardware doesn't just improve performance, it accelerates development timelines. It allows companies and governments to iterate faster, deploy larger models, and push the frontier of artificial intelligence forward. In strategic terms, compute translates directly into power. That is precisely why Washington sought to restrict it. The reported location of these clusters deepens the concern. They were allegedly operating in Inner Mongolia, firmly within Chinese territory. This raises a fundamental question. How did restricted hardware, subject to stringent U.S. export controls, end up powering AI development inside China? The U.S. containment strategy was built around one core assumption: that hardware restrictions are enforceable. Compute power is physical. It must be manufactured, shipped, installed, cooled, and powered. Unlike software, it cannot simply be copied and emailed. That physicality was supposed to make it controllable. But global supply chains are complex, and complexity creates ambiguity. In a globalized semiconductor ecosystem, hardware rarely moves in a straight line. There are intermediaries, third-country distributors, re-export pathways, cloud providers operating through foreign subsidiaries, secondary markets for high-end computing equipment. Even when direct sales are blocked, indirect routes can emerge. A chip may be sold legally to one jurisdiction, then leased, resold, or accessed remotely from another. Cloud infrastructure further blurs the line between physical and digital control. If a Chinese entity gains access to compute hosted outside mainland China, enforcement becomes significantly more difficult. And in a race defined by speed, even small loopholes can compress strategic advantage. Artificial intelligence depends on three core components: algorithms, data, and compute. Algorithms can be replicated. Data can be collected domestically, but compute, especially at the frontier, is scarce, capital-intensive, and geopolitically sensitive. Training state-of-the-art AI systems requires thousands of GPUs operating in synchronized clusters, consuming vast amounts of electricity in cooling capacity. That infrastructure is not trivial, it is strategic. If China can maintain access to advanced compute despite sanctions, the time gap Washington hoped to create may shrink dramatically. The semiconductor choke point was designed as a time-buying mechanism: time for domestic manufacturing expansion, time for allied coordination, time to strengthen supply chain resilience. If that buffer collapses faster than expected, the global AI balance shifts. If enforcement gaps are confirmed, Washington is unlikely to stand still. We may see tighter scrutiny on cloud providers, expanded sanctions on intermediaries, greater pressure on allied countries to align their export regimes. But escalation carries risk. Overly aggressive restrictions could accelerate technological decoupling, dividing the world into parallel AI ecosystems, one centered on the United States and its allies, another anchored by China and its industrial partners. Such fragmentation would reshape global innovation, trade, and military technology for decades. The semiconductor war was never going to be decided by a single regulation. It is a contest between innovation and enforcement, between restriction and adaptation. If advanced AI chips are already finding pathways into restricted environments, containment may be more porous than policymakers assumed. The question is no longer who invents first, it is who sustains advantage under pressure. Because in the race for artificial intelligence supremacy, control only works if it holds. And if the barrier is cracking, the next phase of the AI war may already be underway.